Good evening, students. Today we are going to discuss about the exact differential equation, reducible form. Sometimes we have know that any equation, differential equation which is exact, then it's del m upon del y is equals to del n by del x. But sometimes this is not possible that every equation is exact form directly. We have to reduce it in the exact form by using integrating factors. These integrating factors are mostly 5 types. What is integrating factor? First of all, if an equation is not exact, then we multiply it by a function of xy. This is known as a factor. This is our factor, which is a meaning of the function of x and y. When we multiply it, the equation becomes reduced into the exact form, and this factor is known as integrating factor. As I told you, there are 5 types of integrating factors. We will discuss it about one by one. So there is a first form. If the equation m dx plus n dy can be reduced to the form of exact if 1 by n del m by del y minus del n by del x will equals to fx. Fx means a function of x alone. There is no y. Then the integrating factor will be e to the power integration of f dx. Let us do some example on this, then we will go further ahead. Now this is the example for the form first. I have write the main point of the form first. Now the question is x square plus y square plus x of dx xy dy is equals to 0. First of all, we checked m is here, m is equals to x square plus y square plus x and n is equals to xy. Then what about del m by del y? It will be 2y. And what about del n by del x? It will be y alone. As we can see, these are not equal. It means the equation is not exact. Equation is not exact. So for forming it reduce into the exact form, we will check 1 by n del m by del y minus del n by del x. Let us check what is it. Our n is xy, so it is 1 upon xy. This is 2y minus of y. It means it is 1 upon x, which is the function of x. Therefore, integrating factor will be e to the power integration 1 by x of dx, which will equals to e to the power log x, or you can say x. So just do the one thing, multiply equation 1 by x such that x cube plus xy square plus x square of dx plus x square y of dy is equals to 0 is in exact form. You have to no need to check it that is exact or not. It will be automatically exact. Since this equation is exact, therefore the solution will be integration of x cube plus xy square plus x square dx plus integration of this with no terms of x, there is no term, is equals to c. So it is x to the power 4 upon 4 plus x square y square by 2 plus x cube by 3 is equals to c is the required solution of our given differential equation. So let's do another question for easily concept clearing. Here m is equals to x square plus y square plus 2x and n is equals to 2y. Then what about del m by del x? Sorry, del m by del y, that is 2y. And what about del n by del x? In partial derivative of n respect to x, there is no term of x, that means 0. Equation is not exact. So we can say 1 upon n del m by del y minus del n by del x. Let us check it. Is it a function of x or not? Then why I am using 1 upon n here? Because m is so big. So I will first try with the n which has a single multiple. That means 1 upon 2y, that is 2y minus 0 which will equals to 1. 1 as a function of x, which is a constant. Therefore, integrating factor is e to the power 1 dx, or it is e to the power x. Then multiply the equation number 1 by e to the power x. We get that will be x square plus y square plus 2x e to the power x dx plus 2y e to the power x dy is equal to 0. As we know, the equation will become exact. Equation is exact now. So the solution of integration of this will be x square plus 2x ex plus integration of ex 2y with respect to dx. I could write it again. It will be x square plus 2x e to the power x dx plus y square e to the power x dx plus, here is no term for the n, there is no term which is independent of x, which has no contain x. So there is no term for x, will equals to c. Now integration of this will be x square e to the power x plus integration of this will be y square e to the power x is equals to c. You know why? Why I write it again is here? Because we know that e to the power x, f of x plus f of derivative of x is always equals to e to the power x fx. I use here this formula. So the solution is e to the power x square plus y square is equals to c is the required solution of our given differential equation. Now there is a form number 2. If the equation m dx, for the equation m dx and dy is equals to 0, if 1 by m del m by del y minus del n by del x is equals to a function of y, only y, then integrating factor will be e to the power minus integration of fy dy. We remember there is a minus. Clear? Now let us do some example on it also. Now there is an example for the given form. I have write the short note on the side one. Now here m is y to the power 4 plus 2y, then del m upon del y is equals to 4y cube plus 2. N is xy cube plus 2y4 minus 4x. Then del n by del x will equals to y cube this will be 0 minus 4. As you can see, these are not equal, therefore equation is not exact. And now the m is shorter than n, so I will use this one, not the form number 1. So 1 by m del m by del y minus del n by del x, what is it will be? That is 1 upon y to the power 4 plus 2y. This is 4y cube plus 2 minus y cube plus 4. Then it will be, by solving, this is 3y cube plus 6 upon in the y4 plus 2y, or I can say if 3 is common above, that is y cube plus 2, and y is common from here, it will be y cube plus 2. This will be cancelled out, it will become 3 by y, which is the function of y only. Therefore, integrating factor will be e to the power minus 3 upon y, and you know it will be e to the power minus 3 log y, so I can say it is nothing just 1 upon y cube. So multiply the equation number 1 by 1 upon y cube. What will I get? If I said multiply by it by 1 by y cube, I will get y plus 2 upon y square of dx in the question here. Then plus, when I multiply by it by 1 upon y cube, it will become x plus 2y minus 4x upon y cube dy is equals to 0. Equation is exact. As we know, by multiplying integrating factor, equation will automatically exact. So the solution is m dx plus term of n which do not contain x with respect to y is equals to c. So here m is y plus 2 by y square dx plus the term of n which do not contain x is the only term, that is 2y. It means 2y dy is equals to c. Now integrate with respect to x, taking y as in constant, I will get x y plus 2x upon y square. Here integration with respect to y, I will get y square by 2 से 2 cancel हो जाएगा. It will equals to c is the required solution of the given differential equation. I hope you understand how we'll use it. Now another example for the same form. Here m is 3x square y to the power 4 plus 2xy. Then del m by del x del y will be, you know what is the meaning of del m by del y. If not, then I am again repeating it. This is the partial derivative of m with respect to y, means taking x as a constant. So the derivative of this will be 3x square, this will be 12 x square y cube plus 2x. Here n is equals to 2x cube y cube minus x square. So partial derivative of n with respect to x will become 6x square y square minus 2x. Clear? Now 1 by m del m by del y minus del n by del x will become 1 upon m is 3x square y4 plus 2xy. This is 12x square y cube plus 2x minus 6x square y cube minus plus 2x. Then it will, in the above side, it will become 6x square y cube plus 4x, and this denominator is 3x square y4 plus 2xy. On the above side or from the below side, I can say 2 is common above, that is 3x square y cube plus 2x, and from the here y is common, this will be 3x square y cube plus 2x. This will be cancelled out. I will get 2 by y, which is the function of y only. Therefore, the integrating factor will be integration of minus f of 2 by y dy, which will become, as you know, 1 by y square. So multiply equation number 1 by 1 by y square. When I multiplied it by 1 by y square, I will get 3x square y square plus 2x upon y of dx, plus by dividing this by y square, I will get 2x cube y minus x square upon y square dy. Is it clear? Now, equation is exact. Therefore, required solution is m dx plus n, term of n which do not contain x with respect to y is equals to c. So here is 3x square y square plus 2x upon y dx, plus in the terms of n there is no term which is independent of x, so there is no term with respect to y is equals to c. Now integrate it with respect to x, I will get x cube y square plus x square upon y is equals to c. This is our required solution of the given differential equation. I hope you understand the form number 2 also. Now we'll go ahead for the form number 3rd. So let's start our third form. It says if the equation m dx plus n dy is equals to 0 is a homogeneous equation. Remember, homogeneous, you know what is the homogeneous? The degree of m and n will be same, that is why it is known as homogeneous. And mx plus ny is not equals to 0, means if I multiplied m by x and n by y and then add, and the addition of them is not equals to 0, then the integrating factor will be mx plus ny, 1 upon mx plus ny. We remember this. For this form, equation should be homogeneous. This is the main point of this form. Let us do some example on it. Now here is the example for the form number 3rd. The equation is given as x square y dx minus x cube plus y cube of dy is equals to 0. We have to solve it. As we can see, the degree of m is 3 and degree of n is also 3. Therefore, because the degree of m and n are same, so therefore equation is homogeneous. Since the equation is homogeneous, so first of all I will check m dx, where m is equals to x square y and n is equals to minus of x cube plus y cube. Now mx plus ny will be, multiply m with x, I will get x cube of y, plus multiply n with y, I will get minus x cube y minus of y to the power 4. It will be cancelled out. It will minus 1 upon minus of y power 4. Therefore, integrating factor is 1 upon mx plus ny. As you can see, it is not equals to 0, and I write that mx plus ny should not equals to 0. So it will be minus 1 upon y to the power 4. So just multiply equation by 1 upon y to the power 4, we will get, let's suppose equation number 1. So multiply equation number 1 by minus 1 by y to the power 4, it will become x square upon y cube dx minus से करेंगे तो प्लस हो जाएगा या ऑटोमेटिकली, इट विल बी एक्स क्यूब अपॉन वाई 4 प्लस 1 अपॉन y dy. By using the integrating factor, the equation will become automatically exact. Therefore, it is exact equation. We do not need to check it now. Just solution of this will be m dx plus n, the term which do not contain x, dy is equals to c. So here m is this one. It means minus x square upon y cube dx plus the term in the n which do not contain x is 1 upon y. So it will be 1 upon y dy is equals to c. That means it will become minus x cube upon 3y cube plus log of y is equals to c, which is our required differential form. We can do it furthermore. I can say log of y is equals to c plus x cube of 3y cube, or if I take it log also, then it will become more easier. Let us do that, because constant can be taken as in log. So I can say it is log x, log c. Then it will be log of y minus log of c is equals to x cube upon 3y cube. It will be log of y upon c is equals to x cube upon 3y cube, or y by c is equals to e to the power x cube upon 3y cube, or y is equals to c into e to the power x cube upon 3y cube is the required solution of our given differential equation. This is just a modified form. You can leave it here also. So there is another example for the form number 3rd. Here again we can see the degree of this will be 3, this will be 3, this will be 3, and this will be 3. Therefore it is a homogeneous equation. it is a homogeneous equation of degree 3. Now here m is equals to x square y minus 2xy square, n is equals to minus of x cube plus 3x square y. You can easily see that del m by del y not equals to del n by del x. So I will check, because it is homogeneous, I will check mx plus ny. Mx will be x cube y minus 2x square y square plus ny will be x cube y plus 3x square y square. As I can say, it will become x square y square, which is not equals to 0. Therefore integrating factor will be 1 upon mx plus ny, which is 1 upon x square y square. So multiply the equation number 1 by 1 upon x square y square. So I get the equation, this will become 1 by y minus 2 by x, I hope it will be same, yes, of dx. If I multiply this by this one, I will get the same result I have right here. You can see plus minus, when we will do here, it will become 1 upon xy square minus 3 upon y dy is equals to 0. Now the equation is exact. So the required solution is integration of m dx plus n which do not contain x dy is equals to c. Here m is integration of 1 by y minus 2 by x dx plus the term in n which do not contain x is just 3 by y. So it will be minus minus plus, it will become 3 by y dy is equals to c. Now just integrate it with respect to x. I will get x upon y minus 2 log x plus 3 log y is equals to c. Therefore the required result is x upon y minus c is equals to log x square plus log y cube, or I can say x upon y minus c is equals to log x square y square is the required solution of the, it is not y square, it is y cube, required solution of the given differential equation. Now the fourth form, if the equation m dx plus n dy is equals to 0 is in the form of y fx di, I mean to say is the form of function f1 of xy with y dx plus function, another function of xy with x dy is equals to 0, and mx minus ny is not equals to 0, then integrating factor will be 1 upon mx minus ny. Remember, in this form, equation should be in the form of y dx and x dy with the function of x, y, or another. Let us do some example on it. Now see the example. Since here it is a function of f1 xy with y dx plus f2 function of xy with x dy is equals to 0, and I can check now mx minus ny. So mx, if I multiply this equation by x, I will get x square y square minus 2x cube y cube minus ny. Multiply this part with y, I will get minus x square y square plus x cube y cube. This will be cancelled out. It will become minus x cube y cube, which is not equals to 0. Therefore, integrating factor will be 1 upon mx minus ny, means 1 upon minus x cube y cube. I hope you understand. Am I right or not? Now, if this is our integrating factor, then multiply equation number 1 by minus 1 upon x cube y cube. What I will get? Remember, this y is also there and this x is also there. So it will be, when I divide by this, it will be minus 1 upon x square y plus 2 upon x dx plus, when I used here, by multiplying it, it will get minus 1 upon x y square plus, here it will be y plus 1 upon y dy is equals to 0. It will be exact, equation will exist. Therefore, the solution will be integration of m dx plus n, which do not contain x, dy is equals to c. Here m is this one, so integration of minus 1 upon x square y plus 2 by x dx. The term which do not contain x is 1 by y, so plus 1 by y dy is equals to c. Now integration of this with respect to x will be, this will be x to the power minus 2, yani minus 2 plus 1. It will be 1 upon xy plus 2 log x plus log of y is equals to c. Or furtherly I can say 1 upon xy plus log of x square y is equals to c is the required solution of the given equation. Now the form number 5, if the equation m dx plus n dy is equals to 0 is not exact, and all the four before forms which we have taken is not considered here, then multiply equation by x to the power alpha y to the power beta such that for the alpha beta for some integers of alpha beta, then such that equation become exact. Let us do some example on it. This is the most important form which should have know. By this form we can do any equation in an exact form, but it is a very long method. Let us see how. Now see the equation. Solve this differential equation. Here first of all we have to form in the form of m dx and n dy. So the equation will become 4xy plus 3y to the power 4 dx plus 2x square plus 5xy cube of dy is equals to 0. Now it is in the form of m dx plus n dy. The equation is not exact, as we can see here. Del m by del x, del m by del y is not equals to del n by del x. Then multiply equation x to the power alpha y to the power beta such that equation become exact. When I multiplied it x to the power alpha y to the power beta, it will be 4xy plus 3y4 dx. Again x to the power alpha y to the power beta, it will be 2x square plus 5xy cube with dy is equals to 0. Now by multiplying I will get equation will become 4x alpha plus 1 y beta plus 1 plus 3x alpha y beta plus 4 of dx plus it will become 2x alpha plus 2 y of beta plus 5x alpha plus 1 y of beta plus 3 dy is equals to 0. Now equation is exact. Therefore del m by del y should be equals to del n by del x. So what about del m by del y? It is our m. When we differentiate it with respect to y partially, I will get 4 beta plus 1 x to the power alpha plus 1 y to the power beta plus 3 beta plus 4 x to the power alpha y to the power beta plus 3 will equals to, differentiate this with respect to x, I will get 2 alpha plus 2 x to the power alpha plus 1 y to the power beta plus 5 alpha plus 1 x to the power alpha y to the power beta plus 3. Just equating the like terms, I will get 4 beta plus 1 will equals to x to the power alpha y to the power beta, x to the power alpha plus 1 y to the power beta will become twice alpha plus 2 and 3 beta plus 4 will equals to 5 alpha plus 1, so that our equation will become alpha minus 2 beta is equals to 0, and the second equation will become 5 alpha minus 3 beta will equals to 7. Now just I am going to rub the above part for solving it. By solving, what about alpha and beta? I will get alpha is equals to 2 and beta is equals to 1. Put these values in the given equation, this one which has some form I have शायद रब कर दिया मैंने इसको. It is alpha plus 2 beta and this alpha plus 1 beta plus 3. This is beta plus 4 and this is beta plus 1. Now put alpha is equals to 2 and beta is equals to 1 in equation number 1. We get the exact equation will be 4, when alpha is equals to 2, it is 4x cube y square plus 3x square y5 of dx plus, here alpha is equals to 2, that means 2x to the power 4 y plus 5x to the power 3 y to the power 4 of dy. This is our equation which is exact. So just now we have to solve it and nothing else. So the solution is integration of m dx plus n, the term which do not contain x, dy is equals to c. So here it will be 4x cube y square plus 3x square y5 dx plus the term which do not contain x, there is no term, is equals to c. So the solution will be, by integrating it with respect to x, I will get x to the power 4 y square plus x to the power 3 y5 is equals to c. This is our required solution of the given equation. This method is longer, but it is always give the exact answer for every differential equation in the form of m dx and dy. I hope you understand all the 5 forms which I have told you today. This is the important part, especially for B.Sc and B.tech students. There is always a question is asked in the reducible form. So please do it very carefully, and I hope you understand all the forms. If there is any doubt, you can comment me on the comment box. We practice it. Till then, bye.